Hello everyone, in this lesson we will be discussing partial derivatives. So we have here the definition. If f is a function of two variables, suppose x, y, its partial derivatives are the function, ito. So this is the partial derivative of f with respect to x and the partial derivative of f with respect to y, defined by this one. So this is the limit notation of the definition of the partial derivative. So this is with respect to x. So as you can see, y here is fixed. Okay? So see, y ang fixed. We will treat that one as a constant or a numerical coefficient later in our function. Also, for the partial derivative of f with respect to y, we have x as fixed variable. So that is, now we will treat x as a constant or numerical coefficient later in our problem. Okay? Another way to write the partial derivative is using this notation. So this is just the partial derivative of f of xy with respect to x and the partial derivative of f of xy with respect to y. So ganito lang yung mangyayari dito. If we will solve for the partial derivative of f of xy with respect to x, we will differentiate the function with respect to x only. Okay? That means that y will be treated as a constant or numerical coefficient. Also, in the same way, if we will solve for the partial derivative of the function xy with respect to y, we will only differentiate the function with respect to y. Okay? So para mas maintindihan, let's try this. So we have the function f of xy equal to x cubed plus x squared y cubed minus 2y squared. Now we need to find the partial derivative of f of 2, 1. So that means that we will find the partial derivative at 0.21 with respect to x and the partial derivative of the function at 0.21 with respect to y. Another way to write this is f of 2, 1 with respect to x and f of 2, 1 with respect to y. Okay? So in this case, first we will solve for the partial derivative of f of xy lang muna with respect to x. Okay, so this is just equal to, si x lang yung i-differentiate, so we have 3x squared. X squared is 2x. Then y cubed is a numerical coefficient, so we have 2xy cubed. We copy the numerical coefficient, right? And this will be treated as constant, so the derivative of 2y squared is 0. So we have this. Okay, so from that, we now have the partial derivative of f with respect to 2, 1. The partial derivative of f of 2, 1 with respect to x is equal to, so we will substitute x with 2 and y with 1. So we have 3 times 2 square plus 2 times 2 times 1 cube. So this is 4 times 3, 12 plus 4 is 16. Okay, so that is 16. Okay, or this is equal to f of 2, 1 with respect to x. So another way to write the partial derivative. We also have the partial of f of xy with respect to y is equal to, so derivative of x cubed, so this will be treated as a constant, so 0. And here, the derivative of y cubed is 3y squared. Then we have a coefficient na x squared, so we will copy x squared. So we have 3x squared y squared. Then minus derivative of 2y squared is 4y. So from that, we have the partial of f of 2, 1 with respect to y. Again, that is the same as f of 2, 1 with respect to y. Okay? So that is 3 times 2 square times 1 square minus 4 times 1. So this is 12 minus 4, which is 8. So first, we have 16, and for the second one, we have 8. Okay? So that's it for number 1. Now for number 2, the same process lang. So we have the partial of f with respect to x is now equal to the derivative of sine is cosine, right? Of x over 1 plus y. Then chain rule, derivative of the inside is, so in this case, 1 over 1 plus y will be treated as a numerical coefficient. So we will just differentiate x. So in this case, derivative of x is 1. So we will multiply it by the coefficient 1 over 1 plus y. So that is 1 over 1 plus y. Okay, so this is just 1 over 1 plus y cosine of x over 1 plus y. And that's it. Okay? The same way, we have partial of f with respect to y is equal to, again, derivative of sine is cosine of x over 1 plus y. Derivative of the inside, since our variable is y, which is nasa denominator, so we will use quotient rule. So this is now, copy the denominator 1 plus y. Derivative of the numerator, derivative of x is 0 because x will be treated as a constant, minus numerator, which is x, times derivative of the denominator, derivative of 1 is 0, derivative of y is 1. So we have 1 over the square of the denominator. So we have, this is cosine of x over 1 plus y times, so this is negative x over, this is 0, 1 plus y squared. 1 plus y quantity square. So we have negative x over 1 plus y square cosine of x over 1 plus y. So that's it. Okay? Again, another way to write this is f sub y, which is the partial derivative of f with respect to y, and f sub x. So they are just the same. Lastly, we have this. So the partial of u, partial derivative of u with respect to x is equal to the derivative of arctan is 1 over 1 plus the square of this one, so xy square root of y square, times the derivative of the inside. In this case, this is with respect to x, so the square root of y is a numerical coefficient. Derivative of x is 1, so we have square root of y only. So this is now our final answer. 1 plus square of x is x squared, square root of y, then square is y. Okay? So, ayan. And last, we have the partial of u with respect to x. So, this is, again, the same derivative of arctan. So, 1 over 1 plus x square root of y square times, so in this case, x will be a numerical coefficient, then square root of y is our variable. So that is, square root of y is y to the 1/2. So the derivative is 1/2 y to the negative 1/2. So therefore, multiply it by x. So we have x, okay, x over 2 square root of y. So nilagay ko na agad sa baba. So this is just the same as 1 over 2 square root of y. Diba? Sa baba yung square root of y. So from that, this is now equal to x over 2 square root of y times 1 plus x squared y. So that is our final answer. So I hope may natutunan tayo.